Morning, grade 12 physical sciences learners. The topic for today is the representation of galvanic cell or voltaic cell by means of cell notation or symbolic representation, and also how to calculate the cell potential of the galvanic cell. Electrons are transferred from oxidation half reaction to be gained in the reduction half reaction, or electrons are transferred from anode, pass through salt bridge to the cathode. Oxidation is written on the left, then separated by salt bridge, then on the right you are having reduction. For example, in the zinc copper cell, zinc electrode then is oxidized into zinc 2 plus electrolyte, then separated by salt bridge, then copper ions electrolyte reduced into copper electrode. Oxidation half reaction change is indicated by a diagonal line. For example, a zinc diagonal line, a zinc 2 plus, meaning a zinc is oxidized into zinc 2 plus, so they are separated by diagonal line on the left side, and we know that oxidation occurs at the anode. Separated by a salt bridge is indicated by 2 parallel vertical lines, and reduction half reaction on the right, the change is indicated by a diagonal line. So it means copper ions, copper 2 plus, diagonal line, copper ions are reduced into copper. Then we know that reduction occurs at the cathode. Another example, if we are having 2 moles of hydrogen chloride reacting with 1 mole of fluorine gas, in order to have 2 moles of hydrogen fluoride plus 1 mole of chlorine gas. So what you must do, you must identify the oxidation half reaction and the reduction half reaction by using oxidation numbers, or by using the table of standard reduction potentials as taught in grade 11. The gas is deposited on an electrode, platinum or carbon. Platinum and carbon, they are inert electrodes as explained on the previous audio. So we are having platinum, then you have that diagonal line, the reducing agent, then diagonal line, oxidized species. Then we have salt bridge, which is indicated by 2 vertical parallel lines. Then we have an oxidizing agent, diagonal line, reduced species, diagonal line, platinum. Then what is important is that the gas is deposited on the platinum. Platinum, diagonal line, chloride ions oxidized into chlorine gas, salt bridge indicated by 2 parallel lines, fluorine gas, diagonal line, fluoride ion, fluorine gas reduced into fluoride ion. Then we have a diagonal line, platinum. Then also to calculate the cell potential for today, it is important to know that the voltmeter is used for measuring the work done, which is the electrical energy. The electrical energy can be determined by calculating the cell potential of the cell. The cell potential is also known as electromotive force or EMF of the cell, and is represented by E standard cell, E standard superscript, cell subscript. In the case of galvanic or voltaic cell, the potential difference is established between the electrode and the electrolyte. This potential difference is called the electrode potential. For galvanic cells, is performed under standard conditions known as standard electrode potentials. Then the standard conditions are as follows. The concentration of the solution must be 1 mole per decimeter cube. The temperature must be 25 degrees Celsius or must be 298 Kelvin. The pressure of gases must be 1 atmosphere or 110.3 kilopascal. The redox pair, which is common to all measurements, is called the reference electrode. By international agreement, the hydrogen half cell has been chosen as the reference electrode. Then how to measure the potential of an electrochemical cell using a standard reduction potentials. The one I've been using table is 4B, so it's better to use one table throughout the year. For example, for the copper zinc cell, the formula are provided on the data sheet. E standard cell is equal to E standard reduction minus E standard oxidation, or E standard cell is equal to E standard oxidizing agent minus E standard reducing agent, or E standard cell equal to E standard cathode minus E standard anode. So don't abbreviate this formula, write as they are from the data sheet. Then for this one, the one that is undergoing reduction is copper. Copper ions are reduced into copper. So the value for that reduction half reaction is plus 0.34 volts minus, then the value for oxidation is minus 0.76 volts for zinc being oxidized into zinc 2 plus. So we are having a plus 0.34 minus 0.76. Then the answer is plus 1.10 volts. Then you are having a positive standard cell value. So a positive standard cell value indicates a spontaneous reaction. Another example where we're having 2 moles of hydrogen chloride reacting with 1 mole of fluorine gas in order to have 2 moles of hydrogen fluoride plus 1 mole of chlorine gas. E standard cell is equal to E standard oxidizing agent minus E standard reducing agent. Fluorine gas is reduced to fluoride ions. The value is plus 2.87 volts on the table of standard reduction potential 4B. Minus chloride ions are oxidized into chlorine gas on top of the table. The value is plus 1.36 volts equals to plus 2.87 volts minus in brackets plus 1.36 volts. Then the answer is equal to 1.51 volts. The value of a standard cell is equal to plus 1.51 volts. So it means it's a spontaneous reaction. In summary, the galvanic or voltaic cell makes use of spontaneous redox reactions to convert chemical energy into electrical energy. So in summary, the galvanic or voltaic cell, so they make use of spontaneous redox reactions to convert a chemical energy into electrical energy. Do as many examples as possible for cell notation representation and for calculating the standard electrode potential. Enough for the day.